We've all been there, right? You have this incredible high-end source, maybe a powerful media server, a pro camera,
Yeah.
and then this beautiful 4K display.
Yeah.
But they aren't right next to each other. They're far apart. We're talking maybe 80 meters apart.
That's nearly a football field.
Exactly.
Yeah.
And if you grab a standard copper HDMI cable from a drawer, you're going to get, well, nothing.
A black screen. Physics is the enemy here.
It really is.
Right. Copper has resistance. Over that kind of distance, the data signal, it just degrades before it even arrives. So today we are doing a deep dive into how you beat the physics.
We are.
We're looking at the Kramer CLS-AOCH-60F-262.
It's a bit of a mouthful, I know, but it's an active optical HDMI cable. It runs nearly $400, but it promises to push full 4K 60 Hz video over 262 feet.
Without losing a single pixel.
So the mission today is to figure out what is happening inside that cable to make that possible.
It really starts with that word you used, active. This isn't just a passive wire, it's a hybrid.
A hybrid, okay.
It combines copper wire with OM3 fiber optics.
And that's the key takeaway right there. So it uses copper for things like power and the lower bandwidth data.
The handshakes between devices, yeah.
But the heavy lifting, the actual video, that travels over glass.
Precisely. And inside the connector heads, there's this tiny engine. It's called a VCSE array.
A VCSE array, what's that?
It stands for Vertical Cavity Surface Emitting Laser.
So, practically speaking, the cable takes the electricity from your Blu-ray player, turns it into pulses of light with these lasers, shoots it down 80 meters of glass, and then converts it back to electricity at the TV.
That's it. And using light is really the only way you're going to get the bandwidth you need. We're talking 18 gigabits per second.
Wow.
And that allows for 4K resolution, 60 frames per second, and 4.4.4 color sampling.
That 4.4.4 number is crucial for the pros listening. It means no color compression.
None.
You're getting the raw, uncompressed color data, which is usually the first thing to die over long copper runs.
It is. It also handles the high-end audio, Dolby Digital True HD DTS HD Master audio. But there's another benefit to fiber that people often overlook until they're actually doing the installation.
The size.
The size. This cable is only 4.5 millimeters thick.
That is incredibly thin for an 80-meter run. A copper cable capable of that distance, if one even existed, would be like a garden hose.
It would. It would be thick, heavy, impossible to bend. This has a bending radius of just 20 millimeters.
Okay, so if you're snaking this through conduit or tight corners, that flexibility saves hours of labor.
For sure.
Now, Kramer pitches this for critical AV installations. Think hospitals, control rooms, live events, places where a flickering screen gets people fired.
Yeah, you can't have that.
So how does this cable ensure that reliability?
Well, first, it solves the interference problem. In a big commercial building, you have power lines, Wi-Fi, radios.
Just a ton of electromagnetic noise.
Right. And a long copper cable acts like a giant antenna. It just picks up all that noise, and that can ruin the picture.
But glass is immune to magnetism.
Correct. Fiber has zero sensitivity to electromagnetic or radio frequency interference. So the signal at meter 80 is identical to the signal at meter 1.
Zero attenuation.
Exactly.
And then there's the physical connection. I saw they use K-lock connectors. I'm always a little skeptical of gold-plated stuff. It often feels like marketing fluff.
Well, the 24-karat gold plating is mostly for corrosion resistance, which does matter over time. But the K-lock part, that's mechanical. It's engineered to grip the HDMI port with about 15 pounds of restraining force.
So it won't get pulled out by accident.
It resists that.
Yeah.
Which is vital in a rack where cables are getting jostled all the time.
Makes sense. Okay, we have to talk about safety. If you're running this through a ceiling in a public building, the jacket material matters. This one is rated LSHF.
Low smoke, halogen free. This is a huge deal for building codes.
Why is that?
Because if there's a fire, standard PVC cables burn and they release this thick, black, toxic smoke, often containing chlorine gas.
Which can be more dangerous than the fire itself in a confined space.
Absolutely. LSHF materials don't release those halogens, and they produce very little smoke. In a critical environment like a hospital or an airplane, that is often a legal requirement, not just a nice feature.
It really seems like it's built to survive pretty much anything. It's rated for temperatures up to 50 degrees Celsius, too.
It's a set-it-and-forget-it solution. You install it, and you don't have to worry about handshake issues or HDCP 2.2 errors or signal dropouts.
So, pulling this all together, you aren't paying $388 for a wire. You're paying for a tiny signal converter that bypasses the limitations of copper to guarantee reliability.
That's it in a nutshell. When you absolutely can't afford a failure, you have to use light.
It makes you wonder. Right now, this is pro gear. But as our home consoles push 4K, 8K, and beyond, and our bandwidth needs explode, are we all going to eventually have lasers running through our living room walls just to watch a movie? Something to think about. Thanks for listening to this deep dive.